Hello, this is Jeffrey Fox on the second lesson of this unit on clouds, giving a little more discussion of the details of cloud software architecture, in particular discussing the infrastructure as a service and platform as a service. On top of that, we're going to build software as a service, but that's the actual applications. And these other parts of this class are going to discuss applications. So here we define the so-called players which deliver these parts of it. We have the infrastructure service providers like Amazon, which they may also offer other things like platforms, but they certainly offer infrastructure. Azure, Google, Amazon, Rackspace, they all do that. Then we have the platform providers. That's actually the same people again, but also actually a lot of open source platform providers. There's lots and lots of great Apache products in the platform area, but also there are companies, I don't know, Cloudera is a good example, Hortonworks, which offer platform as a service, as a commercial offering. And then we have various intermediaries who are trying to match cloud providers and cloud users. And then we have application providers providing the actual software as a service. And then we have all of us, the consumers, who use it all. Here is a typical platform. It's, with their endless layered architectures like this. Actually, computing has too many layered architectures. The reason I have lots of layered architectures is actually it's a good way of representing things. But here we have the hosting platform at the bottom. We have networking at the lowest level, then the computers. Then we have the infrastructure services built on KVMs and VM managements like OpenStack and OpenNebula. Then we have the compute storage offered by those services, and of course the network. But this is network as a service. The actual networking itself, it lies below, of course, the hardware. Then we have the platform services. Then we have the shared services, which share between many users, and then you build applications on top of that. These shared services might, I don't know, be um, uh, things that I don't know which cross users. Maybe security is like that. I'm not quite certain. Actually, security is here. So obviously, a service which gave you the time or the weather or something is a shared service. Um, okay, here we have a little more details um, about these various things. The VM servicing systems, the VM systems like OpenStack, they provide a lot of management tools to allow you to provision them correctly and things like that. Platform as a service is so-called middleware capabilities used by lots of different people. And then finally, we have the actual, what counts as the software as a service. Those are the actual applications. All of this is enabled by lots of management capabilities, managing the cluster, managing the accounting, and so on, and security, because we better make certain that we make everything as secure as possible and they will not come and use our cloud. Here's another description of part of the stack, the infrastructure as a service layer, according to Microsoft. And here we have the servers. The servers have one or more VMs. When you look at Azure, Azure is always talking about the fabric controller. All of the what you see is the result is the hypervisor and the VM on top of the hypervisor. For that to work properly requires the so-called fabric controller, which is the software and hardware that basically manages everything. It copes with failure, it copes with elasticity, and so on. And it makes certain that VMs have IP addresses and things like that. So that's infrastructure as a service. It didn't really used to exist as a field, but now is a very important and actually very mature field because it's so important. Here is again a picture of the stack. You go from the physical systems to the virtual systems. You build the IaaS on the virtual systems. You build the PaaS on the IaaS. And then you finish it all up with the applications SaaS. And this is a rather good description of the architecture again, but it's the same architecture. Machines, virtualization, infrastructure as a service, platform as a service, software as a service. And here's yet another view of this. I've actually put network as a service as a layer here. We have the three layers. I've given you examples here. MOOCs would be example of a software as a service. Um, if you do your simulations, that's applications. Here on the platform, you have MapReduce, you have libraries like Saga and Petsy, compiler tools, sensor nets, all sorts of monitoring systems. Then we have so-called software-defined systems built to the infrastructure level, hypervisors, bare metal operating systems. And everything is built, all applications are built with software services, which are either at the platform level or the software as a service level. OpenFlow is a critical technology for building network as a service, which goes nicely with software as a service and platform as a service and infrastructure, which is typically thought of as computing as a service. Notice that all of these ideas are actually true not just for clouds, they're true for standard bare metal clusters. This very systematic way of thinking came from the cloud community. It's not actually the only way that, it's not really to vote just clouds. You can do this, and I think you should do this for essentially all architectures. Here we have another nice layered diagram, a little more layers there. We have a strategy as a service, so that's decision makers at the top. Here we have software as a service. This is designed for business people, business processes as a service. We have collaboration as a service here. Well, we have lots of rules defining how we do things here. Platform as a service, database as a service. I would actually view database as a service as a subset of platform as a service. Here we have governance, analytics. I think all these capabilities are correct, but like many layered diagrams, whether you make it a vertical layer or a horizontal layer, which order you put it in is not at all obvious. Information, security, management, development, government, these are all critical. And then you're enabling all these things. You have a methodology, a process, a repository, tooling, quality of service, life cycle. You have to enabling everything and standards. These all are brought together to build a modern cloud system.